Hello, am I audible and is my screen visible? Can anyone please let me know?
Yes, it's audible.
Okay, thank you. And is my screen visible? Is my screen visible?
Yes, it's visible.
Okay, thank you. Good evening everyone, welcome to this NPTEL live session for the course Introduction to Machine Learning. My name is Oyan Maiti. I am a PhD scholar in the Department of Computer Science and Engineering at IIT Kharagpur. So this is my 5th live session. So in this live session we will discuss some problems on week 5 topics. So in week 5 artificial neural networks and parameter estimation, these were the two topics that were covered in week 5. So we will discuss some practice problems on these topics, and if you have any questions or doubts regarding any thing in these topics, you can ask me. We will start solving the practice problems, and after that if you have any questions or doubts, we will discuss after that. This is the first question. Which of the following are correct regarding perceptron and neural network? So first option is a perceptron will learn the underlying linearly separable boundary with finite number of training steps. Option B is XOR function can be modeled by a single perceptron. Option C is backpropagation algorithm used while estimating parameters of neural networks actually uses gradient descent algorithm. And the final option is the backpropagation algorithm will always converge to global optimum, which is one of the reasons for impressive performance of neural networks. So which of the following are correct? So multiple options may be correct in this question. You can write your answers in the chat. Rijit Saha says option A. Archa says option A, D.
I think option C is definitely correct. A is not correct, B is not correct, C is definitely correct. D, I'm not sure, could be correct. C and could be D.
Okay, C and D you are saying. VG Satish is saying A, C, D. Ritika Geshri is saying C and D. Hazrat B Yarbad is saying A, C, D. Okay, many of you are saying many different answers. So, any other answers? The correct answers are option A and C. So option A says that a perceptron will learn the underlying linearly separable boundary with finite number of training steps. So if the data points are linearly separable, then within finite number of training steps it will be able to learn. So there is a theory regarding that it can be mathematically proven that whatever be the distribution of the data points, if the data points are, if the classes are linearly separable, then perceptron learning will be able to find the decision boundary within finite number of steps. So A is true. And option B is XOR function can be modeled by a single perceptron. So this is not correct. Most of you have already learned that in the video lectures, that in XOR function, if you plot the data points, 4 data points from XOR function, you will see the data points are not linearly separable, and single perceptron algorithm is only able to produce linearly is only able to classify linearly separable data points. So XOR is not. So option B is not correct. Option C is backpropagation algorithm used while estimating parameters of neural networks actually uses gradient descent algorithm. So this is right, that gradient descent algorithm is used in backpropagation algorithm. And option D is the backpropagation algorithm will always converge to global optimum, which is one of the reasons for impressive performance of neural networks. So this is not right, because as backpropagation uses gradient descent, so it might happen that the gradient descent algorithm sometimes will not be able to converge to global optima, and it will get stuck into some local optimum point. So it happens a lot, and it is there is no guarantee that the backpropagation algorithm will find out the optimal weight values of the neural network. So option D is not correct. So A and C, these are the two correct answers here. Is there any doubt in this question? So okay. Question 2. This is a XOR table. So this has also been taught in the video lectures, that XOR table is not linearly separable by perceptron algorithm or any neural network without any hidden layers. So XOR is not linearly separable. So for that, if we use some transformation to transform the points and then do the classification, whether we will be able to do that or not. So which of the following transformations can work? So generally the XOR data points are not linearly separable, but using transformations we can do that. So using transformation we will create or generate new features. Here there are two features, x1 and x2, and y is the output. So we will create new features which are denoted as x1 dash and x2 dash in the options. So we will create new features, and then whether the points will be linearly separable or not, you have to find out that. And the options are different transformations, that x1 dash is x1 square, x2 dash is x2 square, that is the first option. So similarly the other three options are also describing different transformations of the features.
Sir, could you plot the graph for this data set and explain?
I mean, first all of you try and write your answers, then I will obviously discuss how to solve this. So first yeah, you should try this and write your answer. After that I will certainly show you how to solve this. Multiple options may be correct in this case, so you have to try out every option. You have to try out every transformation in these options and see whether points are linearly separable or not. So no one has written any answer in the chat yet. So for this question, as I've already told, that you have to try out every transformation. So first is this option A, x1 dash is x1 square and x2 dash is x2 square. So x1 dash and x2 dash, if we compute for the first transformation, option A, so x1 dash is x1 square, so this will be 1, x1, this will also be 1, and all 4 points will become 1 comma 1. So certainly all 4 points are indistinguishable, so certainly they cannot be linearly separable. If all 4 points land on the same point, then we cannot separate the two classes. So first option, first transformation will not work. Second transformation says x1 dash is 1 plus x1, x2 dash is 1 minus x2. So that means x1 dash,
In the first one, no? In the first option, that is all points are translating to 1, 1.
yes.
So that in effect we have only one input data point, right? 1, 1.
I mean, no, not 4 data points are there. Different data points have different y values, isn't it? Minus 1, 1, 1, minus 1. 4 data points have different y values.
Okay.
So the x coordinate, I mean the features are same for all 4 points, but the output or the target values are different. So that means we cannot distinguish between the two classes. If points are landing on the same point, then we cannot classify them. So that's why first option will not work.
No, as I understand it, like the same input is producing 4 different outputs. Same input,
Yes.
like
Mm-hmm.
x1 is 1.
Yeah, same input, but you have to treat them as 4 different points. Yes.
Okay.
Second transformation is x1 dash equals 1 plus x1, so it will be 0, this will be 2, and then this one will be 2, this one will be 1 minus 1, 2, this will be 0, and this will be 1 minus 1, 2. Sorry, this one will be 1 minus 0, and 1 plus 1, 2, 1 minus 1, 0. So these are the 4 points from the second transformation. I hope I have computed these 4 points correctly. So if we plot them now, so the first point is 0 comma 2, so it will be somewhere here. This is the first point with level minus 1. Second point is 2 comma 2 with level plus 1. Third point is 0 comma 0 with level plus 1, and third point is
Excuse me, in x1 dash the very first value is not 0 but 2.
first x, this one.
Yeah.
One, oh no, no, 1 plus x1, isn't it the transformation?
Okay. Sorry.
and the fourth point is 2 comma 0, is 2 comma 0, which is here -1. So the points will be so certainly the points are again not linearly separable. What were the answers? C, yeah, B is also not correct. This is a positive point, this is a positive point, this one is a negative point, this one is a negative point. So I mean it is the same as the XOR table only. So certainly we cannot linearly separate the two classes here. So similarly again you have to find out this value of the x1 dash x2 dash for the third transformation, like x1 dash is x1 x2, x2 dash is minus x1 x2. So x1 dash would be 1 here, 1 here, and then -1 here, be -1 1, -1 1, and 1 -1. So now first point is 1 -1, which is labeled as negative -1, then -1 1, it is +1, then -1 1 again +1. So the two positive points are exactly same, -1 1 and 1 -1. So the fourth point is also same as the first point. So these are the two negative points, these are the two positive points. So certainly we can find out a linear decision boundary for that. So now the points are linearly separable. So option C is correct. This transformation will be able to linearly separate the two classes, and similarly you have to do it for option D, the fourth transformation, x1 dash equals x1 minus x2 square and x2 dash equals x1 plus x2 square. And if you compute it, I think it will also give you linearly separable data points. So correct answers would be C and D. So if you compute D, it will come out as linearly separable. So this is how you have to do it. You have to compute the two new features x1 dash and x2 dash from x1 and x2, and then you have to plot those 4 points and see whether positive points are separable from negative points or not using a straight line. Is there any doubt in this question? Okay, then we move on to third question. Yes?
How do we mark what? How do we mark the points? Can you explain once again?
No, mark means the y values are given here. -1, 1, -1. These are the y values. Y values would be given. The features you are generating, the new features x1 dash x2 dash, y value remains the same for all the points. Y value is not transformed.
Okay. Okay. Thank you. Darn it.
Now question 3. What is the effect of using activation function fx equals x for the hidden layers in an artificial neural network? So if fx equals x, this is like an identity function. So whatever you give, it will produce that thing only. So it does not transform the value at all, like in sigmoid, ReLU, softmax or tanh, they are the different activation functions. This is one activation function which is called identity activation function. So it does not transform anything of the input. So what is the effect of such an activation function? Option A is no effect. It is as good as any other activation function like sigmoid, tanh. Option B is the ANN is equivalent to doing multi-output linear regression if we use this activation function. Option C is backpropagation will not work. Option D is we can model highly complex nonlinear functions. So which of these options are correct? Multiple options may be correct here. Archa says option C. Backpropagation will not work.
A and D.
A and D. Okay. Anyone else? I've got two answers in the chat. And Dr. Abhishek Mishra says option B. Okay. Harapriya Kaur says option B and C. And the only correct answer is option B. The NN is equivalent to doing multi-output linear regression if we use this activation function. So first option says that no effect, it is as good as any other activation function like sigmoid, tanh, etc. So this is not right. We need to use non-linear activation functions, otherwise there is no point in using hidden layers in a neural network. It would be same as linear regression or logistic regression. The non-linearity of the neural network comes from these activation functions. Otherwise everything is just matrix multiplication. It would become same as some equivalent logistic or linear regression. So effect is not the same, and it is not as good as any other activation functions. Those non-linear activation functions are much more appropriate for neural network. Option B says that the ANN is equivalent to doing multi-output linear regression. So this is correct, that if we use such an identity function as a neural network, so it does not introduce any non-linearity in the output of the neural network. So it would simply become a linear regression but with multiple outputs. In case of general linear regression, there is only one output. Now in case of neural network, we can have multiple nodes in the output layer, so it would become multi-output linear regression, nothing more than that, if we use such a linear activation function.
Can you please explain that point once more? What is this multi-output linear regression?
I mean, so in linear regression, these are the inputs and this is the output. The architecture looks like this, isn't it?
Yes, yes.
So now as neural networks can have multiple output units, so it will have multiple output units, but the job would be same as a linear regression if
Okay,
we use this activation function.
Okay, got it. Thank you.
And third option says that backpropagation will not work. Backpropagation will certainly work. For backpropagation or gradient descent algorithm, we just need the activation functions to be differentiable, so that we can find out the derivative values of the loss function with respect to different weights. So and this fx equals x, this function is certainly differentiable and backpropagation will work. Option D says we can model highly complex non-linear functions. So that is where the problem lies, that if we use this linear function as the activation function for the neural hidden layers, so the neural network will not be able to model any complex non-linear functions. It will only be able to construct linear functions. So that's why it will be equivalent to a linear multi-output linear regression. So option D is also not correct. So option B is the only correct answer. question 4. Which of the following functions can be used on the last layer of an artificial neural network for classification? So for classification, which of these functions can be used as the activation function for the last layer of a neural network? So the 4 options are there: softmax, sigmoid, tanh, linear. VG Satish says option A, Ritika Kesri says option B, Dr. Abhishek Mishra says option B, NS says A, Arijit Shah says AD. So multiple options may be correct in this question. Vinod Govindan says BC. Shruti says option A.
Why is the last layer stressed here? And how is the last layer different from any other inner layer?
That is the question, that in last layer we cannot use all different kinds of activation functions. For classification task, in the last layer we need some specific activation functions, otherwise we will not be able to get the proper output.
So classification has to be discrete output. So in that case, it has to be like I think softmax and sigmoid. B and B.
So the correct answers are A, B, C. So in classification task we need to restrict the value in a given region, and also the output needs to be discrete. That's why we need to restrict it within a small range, and then we can separately predict different classes. So softmax and sigmoid, these two functions are very similar. Softmax is actually a generalized version of the sigmoid. So in sigmoid the value ranges from 0 to 1. So from 0 to 1 the value ranges, and softmax is also similar, but just that it can accommodate more than 2 classes. Sigmoid is only for when you have only 2 classes in the output, and in softmax can be applied when you have more than 2 classes. And tanh is also
Can you please explain how is softmax? Sigmoid understood. Softmax, how does it look?
So I mean the definition is almost same for sigmoid and softmax. It is P
1 by 1 plus e raised to minus 6.
No, that is for sigmoid, it is power minus x, and for softmax it is e to the power minus so 1 minute, if you have multiple outputs, so it would be something like that, e to the power xi x0 plus e to the power x1 plus like this e to the power xc. So if you have c number of classes, so for the ith class this would be the output, basically the probability, and you will pick the class with the highest probability. This is for the ith class. So that would be the definition of the softmax. So basically softmax is the generalized version of this sigmoid if we have more than two classes, because if we it would just become e to the power x plus 1 by so if we have only two classes, soft sigmoid is used, and if you have more than two classes, softmax would be used. But
How does the graph of softmax look like?
softmax would also range from 0 to 1, exactly same, but it would have many different other parameters. Like here we have x0, x1. For different classes we would have different this output values. So the value would range between 0 to 1 again. So and the tan age looks very similar to, I mean, definition is different, but looks very similar to sigmoid, just that it ranges from +1 to -1. So it would look something like this. Whereas sigmoid ranges from 0 to 1, tan age would range from -1 to +1. But again the two functions are very similar, and it can also be, tan age can also be used in the last layer in case of classification. So if the output of the tan age activation is less than 0, so we will pick -1 as the output, and if it is more than 0, we will pick +1 as the output. And similarly in case of sigmoid, we pick that when the output of the sigmoid function is less than 0.5, 0 is picked, and if it is more than 0.5, then class 1 is picked. So that's why these three functions can be used, but linear cannot be used, because linear does not bring the output within a small range, so that we can do the classification task, that we will put discrete values for the different classes. So we cannot do that for linear, but the other three activation functions can do that. It shrinks the output within a given range, and now we can pick different classes by picking a threshold like 0.5 in case of sigmoid, or 0 in case of tan age is the threshold. Is there any doubt on this question?
So can you explain one question from week 5? The question alone I need to understand. The concept I don't know. What is the question?
If you need any clarification regarding that question, so it would be better if you put your question in the discussion forum, because the week 5 is not over yet, the assignment is not over yet. So
no sir, my question is not regarding the answer. My question is, they have given the, as you told, the sigmoid functions and all, right? Sigma of x is 1 by 1 plus whatever expression you have done. The question is about tan h of x, whether it represents the derivative or what we need to do. That.
I didn't hear you properly. Can you repeat your question?
Sorry?
I cannot understand your question properly, so can you repeat your question?
Priyanka, I think tan h stands for hyperbolic tan, and the graph of range is as drawn in the board. It ranges from -1 to +1.
Yes, ma'am. But in option like tan h dash of x, my question is tan h dash of x and tan h of x. Both are same or it is different?
Tan h of x.
Yes. Tan h
how can these two be same? These two cannot be same, certainly. Tan h is a specific. No, these two are not same. So now I don't know the question, what the question actually asks. So but those two are completely different. Tan h has a different definition in terms of the exponential function. It has a definition. So tan h of x is not equal to tan h of x, certainly.
Okay. Okay, thank you.
Question 5. There is a statement and there is a reason. Statement is threshold function can be used as a activation function for hidden layers, and reason is threshold functions do not introduce non-linearity. So threshold function is basically like this, like 0 and 1. There are two output values of a threshold function, 0 up to certain point, and after that point it is 1. So this is threshold function. So statement is that it cannot be used as an activation function for hidden layers, and the reason is threshold functions do not introduce non-linearity. Now you have to state whether the statement is true or false, and the reason is true or false.
I think both statements are false.
Okay. Any other answers?
There is no. One of the statements has to be true.
Rijit has written option B. Statement is false, reason is true. Okay. The correct answer is statement is true, but the reason is false. So statement says that the threshold function cannot be used as an activation function for hidden layers. So this is true, that it cannot be used because it has only two output values, 0 or 1. These are the two values that it can output. But in case of neural networks, just two values in the hidden nodes are not enough. Then it will not be able to generate many different outputs. It will be the output would become very restricted within a given range only. So that is not good for neural networks. We need the hidden layers to output many different values, but here in threshold function can output only 0 and 1. So that is not good for this. Also there is a problem that it is not linearly, it is not differentiable. So this point, at this point it is not differentiable because 0 and 1. So that is also one of the reasons why it cannot be used. And the reason says that the threshold function do not introduce non-linearity, which is false because the this threshold function is certainly not linear. This part is linear, this part is linear, but overall this is not just a straight line. So this is not a linear function. The threshold function contains linear segments separately, but not a linear function. So it can introduce non-linearity, but that is not the reason why we cannot use this threshold function in the hidden layers. We cannot use because it has only two outputs, but we need different outputs for different inputs. Many different outputs we want from the hidden nodes in case of neural networks. So that's why option A is correct, that statement is true, reason is false. And question 6, we use several techniques to ensure that the weights of the neural network are small, such as regularization and random initialization around 0. These are the different techniques that are used to ensure that the weight values are small and closer to 0. What conclusion can we draw if the weights of our ANN are high? So what will be the conclusion if the weights of the neural network are high? So there are four options. Model has overfitted. it was initialized incorrectly. At least one of the A and B option, and the option D is none of the above.
C, I think option C.
Okay.
I think it's A for sure. But,
Okay. A. VG Satish is saying option A. Hajarat B. Arwar is saying option A. Shaikh Mansoor is saying option D. Okay, many different answers I'm getting. Ritika Keshri is saying option B. So the correct answer is option D. We cannot conclude any of these things that are given in the option from if the weight values are high. So the first option says that overfitting, the model has overfitted. Overfitting, the overfitting might also happen because of many different other causes. Not just that the weight values, not just that the model has overfitted, that's why the weight values are high. It might not happen. Even with smaller weight values, the model might overfit. So A option is not for certain, we can say that this is the reason, and the overfitting is not associated with the high weight values. And option B says that it was initialized incorrectly. Even if the points weights are initialized incorrectly, it doesn't mean that it will always remain high. The values will always remain high. So this is also not associated with it. So it can have. So we cannot conclude for sure if whether the model is overfitted or the weight values are initialized incorrectly. So that's why option D is the right answer. That none of the above would be the conclusion if the weight values are high. So weight values might be high because of higher learning rate. It can also be because of the nature of the data set. The data points such that the weight values are high, but it does not mean that model has overfitted or the points weight values are initialized incorrectly. Lakshmi, do you want to say something? Your microphone is unmuted.
Sorry.
Question 7. Which of the following are true when comparing ANNs and SVMs? ANN error surface has multiple local minima, while SVM error surface has only one local minima, Option B, after training, an ANN might land on a different minimum each time when initialized with random weights during each run. Option C says that as shown for perceptron, there are some classes of functions that cannot be learned by an ANN, and SVM can learn a hyperplane for any kind of distribution. Option D says that in training, ANN's error surface is navigated using a gradient descent technique, while SVM's error surface is navigated using convex optimization solvers. So multiple options may be correct in this question. Dr. Abhishek Mishra says option C. Harapriya Kaur says A, B, C. V. Mohan says B and D. Archa says B. Shaikh Mansoor says C and D. Arijit Shah says A, B, D. So first option says that ANN error surface has multiple local minima while SVM error surface has only one minima. This is absolutely correct. ANN error surface is not a smooth error surface. It can have multiple ups and downs, so the different local minimas and maximas can be present in the ANN error surface. But in SVM there can be only one minima, and that is by maximizing the functional margin, so that SVM can only find out one linear decision boundary between the two classes. So there is only one minima in case of SVM error surface. Option B says that after training an ANN might land on a different minima each time when initialized with random weights during each run. So this is also right, because there are many different local minima present in the error surface. So gradient descent algorithm will run differently on different runs. For different initialization of the weights, it can get stuck into a different minimum point. So option B is correct. Option C says that as shown for perceptron, there are some classes of functions that cannot be learned by an ANN, and SVM can learn a hyperplane for any kind of distribution. So this is not right. ANN theoretically can learn any kind of function and can model any kind of function. So option C is not correct. Option D says in training ANN's error surface is navigated using a gradient descent technique, while SVM's error surface is navigated using convex optimization solvers. And this is certainly correct. We know that gradient descent is used to find out the optimal weight values for ANN, and in case of SVM different convex optimization solvers are used. So A, B, D, this is.
Sir, can you explain again why option C is not correct?
Option C says that there are some classes of functions that cannot be learned by an ANN, but theoretically it is known that ANN can learn any kind of function with proper number of hidden layers and hidden units. It can learn any kind of function. So that's why the option C is not correct.
And is it true to say that SVM can learn a hyperplane for any kind of distribution?
SVM can, if the data points are linearly separable, then it can learn a hyperplane for any distribution. So that part is correct, but ANN can also do for any kind of data distribution, any kind of functions. It doesn't have to be linearly separable in case of ANN.
So ANN is more powerful than SVM, because SVM.
But in SVM we can also make it powerful using the different kernel techniques, like Gaussian kernel and other kernel techniques are there. Using those techniques we can make SVM more powerful, and it can also model nonlinear functions, and it can also classify nonlinear data points using those kernel techniques.
Okay.
So A, B, D, these are the three correct answers.
Okay, moving on.
This should be option C is not true. It should be. Here it is written D. So I will correct that before uploading this. Option C is not correct. So it was written wrongly as D here.
Sir?
Yes?
Sir, in my portal it is not showing any videos. It's showing only one video.
How is that possible?
Many
On the left hand side you have all the different weeks, and under different weeks tab you have those video lectures.
Sorry?
On the left hand side of the web page you have different weeks, and under each week you have those different video lectures, isn't it? So
No,
week
sir.
1, week 2, week 3 in the course web page you can see this.
No, there is no video. In that class problem solving session, Jan 24. Only I can see this, but in each weeks there is no videos uploaded.
I'm not aware of this problem, so you have to contact NPTEL for that. You can post your query in the discussion forum. NPTEL admin should be able to solve that, I think.
Okay, sir, thank you. Means if it is we attend, then only the video will be uploaded, or
No,
it will
video,
be-
the up to week 5 or 6 the video lectures are already are you saying the video lectures of these?
not just the problem solving session I'm speaking
Okay,
about.
in the problem solving session you can the problem solving session tab is there in the left hand side.
Yes, there I can see only one video of Jan month.
One video, are you able to open that Excel sheet from there?
There is no Excel sheet here, sir.
Others, can you see the sheet and find out those videos?
Yes, sir.
Yes, sir.
Yeah, it is available for everyone. If you can't see all the videos, then you have to contact NPTEL. The sheet is public, Excel sheet is public, and anyone can see all those links that are uploaded there.
Okay, sir, I'll check with that. Thank you, sir.
The question 8 says that you are given a neural network. So this is the neural network which take binary input values x1 and x2. So x1 and x2 both can take only two values, 0 and 1, and the activation function used is threshold function. So the output is 1 if x is greater than 0, otherwise it is 0. So that's why it uses threshold function. Which of the following logical functions does it compute? So these are the weights of these links.
A and B.
A and B. No, it cannot compute two logical functions simultaneously. OR and AND, these are two different gate functions. Arupriya Kaur says A, Vinod Govindan says A. Archa says A. Meenakshi says A. Okay, most of the answers in the chat are A. So this function basically computes 8x2 plus 8x1 minus 4. Using these weights we can write this expression. It computes this, and if this is greater than 0, then the output is 1, otherwise the output would be 0. So if we plot it, x1, x2 and hx, so this expression is hx. So for 4 different combinations of x1 and x2, what would be this 8x2 plus 8x1 minus 4 value? So first one would be minus 4, so it would output 0. Second one would be 8 minus 4, 4, so it would output 1. For third it would be 4, so it would output 1, and for the final input 1 1, it is 16 minus 4 12, so it would also output 1. So for 0 0 the output is 0, for 0 1 output is 1, for 1 0 output is 1, for 1 1 output is 1. So these are the outputs 0 0 1 0 1 1 1. So we can see that it is OR gate. So option A is the correct answer. So basically you have to compute this expression, and if this expression is greater than 0 then output is 1, otherwise 0, and then you have to check whether it is an OR gate or AND gate or NAND, whatever would be the options. Question 9. Choose the correct statement. Multiple options may be correct. This is on parameter estimation. MLE is a special case of MAP when prior is uniform distribution. MLE acts as a regularization for MAP. MLE is a special case of MAP when prior is a beta distribution, and MAP acts as regularization for MLE. So multiple options may be correct here. MLE stands for maximum likelihood estimation, and MAP stands for maximum a posteriori estimation. The correct answers are A and D. So MLE is a special case of MAP when prior is uniform distribution. So in MLE we maximize probability of X with parameters theta, and this is for MLE. And for MAP we maximize probability of X parameters by theta into probability of theta. So this is an extra term that is used in MAP, probability of theta, which is the prior distribution for the parameters theta. So if this p theta, if this p theta is uniform distribution, then we don't need p theta in this maximization process. So it would simply become maximum of px parameterized by theta. So it would become same as MLE. So that's why MLE is a special case of MAP when prior is an uniform distribution. And option D is also correct, that MAP acts as regularization for MLE. So this p theta term acts as a regularization for the MLE, that by introducing this p theta term, now the optimization process tries to take the prior distribution into consideration also, and it acts as a regularization, just like the regularizers that are used in logistic regression to reduce the values of the parameters. Similarly, this p theta terms tries to give a prior distribution, and it tries the optimizer tries to maintain that prior distribution in its output. So that's why this also acts as a regularizer for MLE. So A and D are the two correct answers.
Can you just explain once more how D is true? D. MAP access regularization for MLE.
So this is the normal MLE. It does not use any kind of prior distribution of the parameters. But in MAP, this p theta is the prior distribution that we use. So this maximization process tries to keep those prior distributions also into consideration, but MLE does not consider any prior distribution for theta. So this is how it applies the regularization. So based on the prior distribution p theta, the optimization would shift towards that distribution. Just like
full form of MAP is maximum
a posteriori distribution.
What?
A posteriori, maximum a posteriori distribution. So it basically maximizes the posterior distribution, which is given by probability of theta given x, and then using Bayes theorem you can write it as probability of x given theta into p theta. So this is only MLE and this is prior. When you combine these two, it becomes posterior distribution. And in maximum posterior distribution, it tries to maximize this posterior distribution with respect to theta.
The way we use this MAP and MLE.
MAP, MLE are used in many all different kinds of parameter estimation, where you have the the distribution and the data points you can collect, but you don't know the underlying distribution and the parameters that it follow. So in those cases, these parameter estimations are used. And parameters are everywhere in the machine learning algorithms also. The weight values of the neural networks are also parameters. In case of clustering, it is heavily used to find out parameters of mean and the centroids. So all those are considered as different parameters, and then by estimating those parameters, we find out the distribution of the data points x. Now question 10. Suppose you have inputs x, y and z with values -2, 5, -4, and you have a neuron q, which is this one, and a neuron f. And q is computed as x plus y, as shown in this figure also, and this f is computed as q into z. So this is a computation graph, also a small neural network. So what is the gradient of f with respect to x, y and z?
So is it -4, -4, 3?
-4, -4, 3. Okay. So for this question, you have to express f in terms of x, y, z, because you have to find out the gradient of f with respect to x, y, z. It is given that f is equal to q into z, and q is x plus y, so it is x plus y into z. Now f is a function of x, y and z. Now you can take the derivative of f with respect to x, y, z separately. So derivative of f with respect to x should be z only. We can express it as x z plus y z. So with respect to x, derivative is only z, which is -4, and similarly derivative of f with respect to y is also z, which is -4, and then derivative of f with respect to z So it would be x plus y because of this expression. So x plus y is 3, so it's minus 4 and 3. So these are the three answers here. Is it understandable?
Can you explain again, sir, this question?
F is q into z, that is already given, and q is x plus y, it is given here. So you express f in terms of x, y and z only. So this is the expression we get, x plus y into z. So we can expand it as xz plus yz. Now we can take derivative of this expression with respect to x, y and z separately. If we take derivative of f with respect to x, so this z only remains, this derivative with respect to x becomes 1, and derivative with respect to of this yz term with respect to x would be 0. So it is only z which is minus 4. So similarly you have to take the derivative of f with respect to y and z also. So correct answers are minus 4, 3. And now question 11. So this is the last question of this session. In training a neural network, we notice that the loss does not decrease in the first few starting epochs. What can be the reason for this? The learning rate is low, regularization parameter is high, stuck at the local minima. All of those could be the reason. So if the loss does not decrease, then what is the reason for that? Multiple options may be correct here.
Sir, option D is correct.
Option D, okay. Archer says BC, Muhammad Baq Kamaluddin says D. So correct answer is D, that all these three options can be the reasons. A, B, C, that if learning rate is low, loss will decrease very slowly, so it might happen that it is not decreasing over a few iterations. And if the regularization parameter is high, so it is giving much more importance to the regularization parameter, and it is not able to decrease the actual loss function. It can also happen, and it might also get stuck in a local minimum point. In that case also the loss would not decrease. So that's why option D, that all of the above could be the reason. So option
Can
D.
you please explain number B for Bombay, how regularization parameters high means what actually?
So the regularized loss function is constructed as the MAC error plus the regularization component, isn't it?
Yes.
So if the regularization component is very high, so it is trying to optimize the regularization component, it is not trying to optimize this MAC error which we actually want. So it is trying to keep the regularization value closer to 0, so it is not optimizing the actual MAC loss.
Okay, got it. Thank you.
Yeah, so these were the practice problems that I wanted to discuss today. Now if you have any other questions or doubts, you can ask me now.
Sir, what is prior distribution?
Prior, as I already talked, that this is the likelihood and probability of theta. This is the prior distribution, and this is the likelihood. Is there any other questions? Lakshmi, do you want to say something? Your mic is unmuted. Okay.
Sir, assignment 4, 2 question I am unable to solve.
Which were the questions?
Question number, I think 3 and 4.
The solution is not out yet for that assignment?
No. But so in the solution also, in the earlier assignment, what I see, they are giving only the answers. How to solve this problem.
2 and 4.
3 and 4. 3 and 4.
3 and 4. You can learn zero classification error on the training data. So question 3, you just have to check whether the points are linearly separable or not. If it is linearly separable, perceptron can certainly classify those points and the classification error would be 0, isn't it?
We have to plot the data.
Yes, just plot those data points and check if the points are linearly separable. Perceptron will only be able to separate linearly separable classes. So just check whether the points are linearly separable or not. If those are linearly separable, then it is yes, otherwise not. And 3 and 4, you said?
And answer true, and the fourth option is true only if we normalize the feature vectors before applying PL. What is the difference between these two options? First option and last option.
Only if we normalize the feature vectors before applying PLA. But the correct answer would be false anyway, isn't it? You don't have to check whether what the last option is. The correct option is false, isn't it? The points are not linearly separable normally.
Yes, yes. But I am confused among between these two options.
I am also not able to understand the reason, but anyway it is certainly false. That points are just, you have to check whether points are linearly separable or not.
So if it is separable, then it will be only true, no?
Yes.
Okay. And question number 4 and question number 4.
4 is using programming, so you have to write the program for this.
So this type of question will come in the exam, or?
Exam, I don't know what type of questions will come. I'm not sure what kind of questions will be given in the exam. But in this case, you have to write the program, otherwise you will not be able to solve this one. It is already written that you have to use sklearn to solve this question. So it has to be programmed.
Okay. So
Like suppose we don't. First of all, this sklearn wasn't taught to us. We don't know Python.
No, programming. I mean, no, programming will not be taught thoroughly in this course. Obviously, programming you have to learn on your own, and then you have to apply the methods that have been taught in the class.
Okay, great. Can you just at least give the formula for this question number 4?
There is no formula. I mean, if you know Python, how to use Python functions, sklearn is a Python library. You have this.
No. That's understood. Suppose, I know. I'm just asking you the theory. Which is the equation we have to use? sklearn, that's a different thing. Okay, I agree. But
in case of question 4, you have to use Python programming. Otherwise, this question you cannot solve here. That how many support vector points would be there. So the sklearn will tell you how many support vectors are there after training the model on this dataset. With these hyperparameter values are also given, that degree equals 3. C equals 1, gamma equals 0.1. So all these things will be taken as inputs to the sklearn support vector machine package, and it will give you number of support vectors.
And question number 2 in the same week 4, question number 2, consider a soft margin game with a linear kernel and no slack variables trained on endpoints. The number of support vectors returned is k. By adding one extra point to the data set and retaining the classifier, what is the maximum possible number of support vectors that can be returned?
Initially k number of support vector points are k may be anything, but once you put one extra data point, so now the whole equation would change. I mean the data distribution might change in such a way that now all n plus 1 points might become support vector points. So it is possible that all n plus 1 points are support vector points. So that's why n plus 1 is the correct answer here, that by introducing one new data point, now the data distribution becomes completely different. So maximum possible support vector points will become n plus 1 only. Just like in case of n points, the maximum number of support vector points would be n. So here it would become n plus 1.
Okay, then question number 6. In SVMs, a large functional margin represents a confident and correct prediction. Let the functional margins be defined as y cap I equals to yi multiplied by w transpose.
In this question, you are just scaling up the weight and the bias by 2 times.
Yeah.
So scaling doesn't change the decision boundary. So that's why the decision boundary would remain the same. The decision boundary is w transpose x plus b, so that would remain the same.
Okay. And next question, that is consider the optimization problem, minimize x squared plus 1 such that x minus 2 into x.
So can you repeat the question number 6 again, the reason?
So in place of w you are writing 2w, in place of 2b you are writing 2b. So we are just scaling those weights and biases by 2 times. But in case of straight line, even if you scale the bias and the weight values up or down, it doesn't change the straight line. So straight line is w transpose x plus b equals 0, isn't it? Here the decision boundary is w transpose x plus b equals 0. So even if you multiply 2w and 2 beta, the straight line remains the same. So there will be no change in the classifier.
Okay, next question, consider the following optimization problem, minimize x squared plus 1 such that x minus 2 into x minus 4 less than equal to 0. Select the correct options regarding this optimization problem. Strong duality holds, strong duality doesn't hold, the Lagrangian. Actually, I'm not really familiar with what is duality and Lagrangian.
That you have to go through those lectures again. Lagrangian formation is the Lagrangian is formed like this: x square plus 1 is the actual function, plus alpha would be the, here in this case lambda is the Lagrangian multiplier into the function that is given as the condition x minus 2 into x minus 4. That would be represented there. So you can go through those lectures again, though that part only where the Lagrangian multiplier formation is given, Lagrangian formation is given. So if you put those things in, it would be this L x plus lambda, that is the Lagrangian, would come out to be this one.
What is the meaning of duality?
Duality is the actual problem is primal problem, and you form a dual problem of that, and if the solution to the primal problem is equal to the dual problem, it is called strong duality. So you have to go through those lectures again. It's a lengthy discussion there in the SVM, so you have to go through those parts again, where this duality is taught, that the optimal solution, primal solution is same as dual solution of the duality problems, then strong duality holds.
But I believe that in the video lectures he has not explained what is primal and dual. He has just
no, it were taught with respect to this SVM problem. It was taught that what is the primal problem and what is the dual problem of that, and based on that you have to form the Lagrangian, and then the Lagrangian is actually optimized in case of SVM.
Okay.
So how this equation comes?
Lagrangian formation, that is already given in the video lecture, that the function here is this x square plus 1, and the condition is x minus 2 into x minus 4. You have to expand this condition part, x minus 2 into x minus 4. Now you have to combine these two using this Lagrangian multiplier lambda, and you would get this formation. You can just search in the internet. It's pretty simple to construct a Lagrangian from the given optimization problem. You can follow the steps used in the SVM. There are certain conditions, like the functional margin condition was there, that yi w transpose x I plus beta is less than equals 1, greater than equals 1. That was the condition, and the actual optimization problem was the w square, minimizing w square. So that was the actual problem, and those were the conditions, and how to combine these two and form the Lagrangian. You can follow the video lectures there. Same process will be applied on this problem. Okay, if there are no other questions, then we can end this live session here. Thank you everyone for joining.
Thank you, sir.
Thank you.
Thank you.
Thank you.